Here's another example where we want to find some k value given that 3k plus 1, k, and negative 3 are consecutive terms of an arithmetic sequence. So this is kind of like, you can consider this a first term and a second term and a third term. We don't know where they fall, but they're at least consecutive. And really the key is that these are all in an arithmetic sequence, so that tells us there's some common difference between all three of these numbers. Now, at first, this might seem kind of difficult, or how do we figure out, do we guess and check? There is a method that we can solve this, find this k value. There's actually kind of two methods that I'm going to show you. But standard operating procedure here is to consider this kind of like in a few slides or a few videos ago, we talked about that if we have three consecutive terms, A, B, and C, we said that B was like the average of A and C. If you kind of remember, we talked about that because by virtue of it being smack dab in the middle of A and C, it has to be the average between those two. So we can kind of consider this K to be the middle between 3K plus 1 and negative 3. So the first method is going to kind of leverage that fact. K is going to equal the average of 3K plus 1, and then that other term on the other side of it, negative 3, and we're going to divide that by 2 since it's the average. So remember, I just set this equal to k because k is the middle term here. So then if I multiply both sides by 2 to solve for k now, I multiply by 2 and I multiply by 2. So I get 2k equals 3k, looks like minus 2. So I can rearrange this equation a little bit, so I get negative k equals negative 2. And therefore k must equal 2. So that's kind of method 1. I can find that k value. And you could check this actually. If I plug in 2 for k, this will be 6 plus 1, so that's 7, then 2, and then negative 3. And if I had 7, then 2, then negative 3, it looks like my common difference is subtracting 5, and that holds up. The other method might seem easier, might seem more difficult, but choose whatever works for you. And that kind of leverages the fact that there is a common difference between all of these terms. So if I consider, let me actually get rid of this arrow here. If I consider the order of these terms, let's say this is like the first term, this is the second, and this is the third. Now again, like I don't know that these are the first, second, and third, but let's just pretend they are. And if I take the third term, let's say u sub 3 minus u sub 2, that should equal the difference between u sub 2 minus u sub 1. So this is, if I take the difference of this minus this, it should equal the difference of this minus this. And what we're going to find is we can actually solve for k that way. So let's rewrite this. Let's take the third term, so negative 3 minus the second term, k, is going to equal the second term, k, minus the first term, 3k plus 1. Notice the use of parentheses here. I'm subtracting the entire first term, so I'm wrapping all this in parentheses. And then let's solve for k. So negative 3 minus k is going to equal k minus 3k minus 1, pushing that negative through. So we'll simplify this further. Negative 3 minus k equals negative 2k minus 1. Let's add the 2k over here, and then we'll add the 3 over to the other side, and I get k equals 2. So same answer of k, just a different method. Whatever works for you, choose the method that makes most sense to you, and try this example. So pause the video, give this one a shot, see if you can find that k value. And remember, you can check it by actually plugging it back in. Turns out k is equal to 0. So the three terms in the sequence are negative 1, 3, and 7, all with a common difference of 4.